which quiz and which problem. Okay? So let's do it. Which quiz and which problem? Who has a question? Let's go. Raise your hand or we're moving on. We got a lot to do today.
I have a question. I just don't know which one.
I can't help you, Clara. Sorry.
Okay.
So, who? Yes, Gabe?
Actually, yeah, number two with one heart. It says sketch.
One heart? All right. So, we're going to sketch a curve. All right, so we got to remember what our general shapes look like. And if you just graph your general shape, you get half credit for just knowing, okay, this is a sign, that's what a sign looks like. Now, to get full credit, you have to do all of your labels. So we have a top and a bottom label, which those are really easy. Those are just the amplitude number out here. So that's 4 and -4. So my amplitude is 4. And these labels should be 90, 180, 270, and 360. Right? Right off of the unit circle, or right off of your coordinate axis system. But this guy right here divides. That divides those horizontal labels. So all these are getting divided by 2. So the real labels are 45, 90, 135, and 180, which makes your period, if you had to list that, 180. Okay? If this had been a cosine problem, it would be exactly the same, except the shape you would be using would start up here. So this would be your cosine, but otherwise all the labels, everything is exactly the same. All right, who else has a question about one of these problems? All right, let's get our practice test out, and we're finishing up number 3. Finishing up number 3. So our test will be Tuesday. That is the next time I see you.
Oh, so I don't gotta take it early?
And nope, and it's gonna look exactly like all of these practice tests that look. So, according to my notes, we're on practice test 3, and we're ready for problem 5E. So 5E says find the cosine of 7 pi over 4. 5E, we're finding the cosine of 7 pi over 4. So what is the first thing we do?
Divide by 4.
We figure out what angle we're talking about. So 180 divided by 4 times 7, that's going to be 315. Now you will have an I-step calculator, one of those little I-step calculators, to help you with this kind of arithmetic, if you need it. Okay, so then, once I figure out that's 315, I am not done. This problem says find the cosine. The cosine is a fraction. So I need to draw my picture. 315 degrees is all the way over here. Remember, in regular trigonometry, these are your labels. So 315 is going to come all the way over here after 270, but before 360, before we get all the way around. Right? Now, that angle is formed by these two fingers right here. There's a finger on the 315 line, and there's a finger on the 360 line. What's the distance between those two fingers? What's the distance between 315 and 360? 45. And that's the key right there. That angle is the important one. Don't care about any other angle in the whole picture. That's the one I want. That's a 45, so I have sides that are 1s and a hypotenuse that is root 2. Right? Now, what do I always caution you about at this point? Negatives. You've got to pay attention to the negatives. What's negative in this picture? Is that negative? No. Is this negative? Yes. Is this negative?
No.
Never. Never will that be negative. All right, cosine is adjacent over hypotenuse.
1 root 2
So
over 2.
1 root 2 over 2 is the answer to the question. I think there's one more of those. And it is cosecant, cosecant 7 pi over 6. So think about the steps we just did and do the same steps. So what's the first thing we have to do? Divide 180 by 6 and multiply by 7, or somehow do that arithmetic.
I think he's missing from when Mr. Knoll was gone. Or-
Okay, is your name on them?
Yeah.
Okay, thank you.
210.
That's 210, that's right, cosecant 210. Now, I bet my allowance that somebody's gonna put 210 down as the answer. It is not. You need the cosecant, so your answer needs to be a fraction.
You look
So
good out
to
there.
find the fraction, we're gonna draw 210. Does everybody have it drawn down here like this? Because it's between 180 and 270,
Struck by the beauty of this highly educational American city.
Right.
Here's this man out here that's
there's my triangle.
coming in and he's doing his job.
Now, see my fingers? The angle I'm looking for is between 180 and 210. So that's 30, which means that's 1, that's 2, that's root 3. And then I stop and add any negatives that need negative. Does the root 3 need a negative?
Yeah.
Yep. Does the 1 need a negative?
Yep.
Yep. Does the 2 need a negative?
Never.
Never. Never.
Oh.
I want the cosecant. Well, cosecant is the reciprocal of the sine. Sine is opposite over hypotenuse, so I need hypotenuse over opposite. So that's going to be 2 over negative 1. There's my fraction. The answer is always going to be a fraction for problems that say find the cosecant or find the cosine. Those are fractions. So the answer is negative 2. Alrighty? Now, I need the secant to be negative. Remember, less than 0, that's a less than 0 is negative. And tangent to be negative. Okay? Now, let's start right here. Secant, reciprocal of cosine. Cosine is which letter, X or Y? X. Cosine is X. So what this is really saying to me is X is negative. So think about your coordinate axis system. Where will the X be negative?
To the left.
On the left. So right now we're talking about these two quadrants, right? X negative, right here. Now think about if you drew a triangle in these two quadrants, this side would be negative, right? Here, that would be positive and this would be negative. Would you agree with me? Now, tangent is opposite over adjacent. If it's confusing to have both triangles in one picture, you can draw them in separate pictures.
So
That's negative, we know. That's positive, that's negative. Here, opposite over adjacent would be negative, wouldn't it? Isn't that what we want? So this is your quadrant. Here, opposite over adjacent would be positive. So that isn't what I want. So the answer to the question is quadrant 2. Those are easy problems if you remember that cosine is x and sine is y, right? Okay, now we're going to do some sketching. Remember, all this is happening without your regular calculator. This is all happening with an I-step calculator. All right, so y equals 2 sine 1 third x, and y equals tangent 2x. Okay, so here we go. Sine. First thing I'm going to do is draw my curve. That's what a sine looks like. Okay? Now, that number right there on a sine or a cosine, that number right there tells me my vertical labels. My vertical labels. That's also telling me my amplitude is 2. All right? Now, these labels, top of the hill, where we cross, bottom of the valley, where we end, those labels are supposed to be, well, normally 90, 180, 270, and 360. But they're not in this problem, are they? Because we put that number in there, right there. What does that number do?
Times it by 3.
Yeah, well, it divides all of these by a third, and I want you to think about it as a division, so you don't get confused. It's a division. Now, it just so happens that dividing by a third is the same as multiplying by 3, but you don't multiply by this number. This is a division. So this is going to become 270 because it's 90 times 3 when you actually do the work. And then this one will be 540. And this one will be 810. And 1080 again. So my period, my amplitude was 2, and my period is 1080. From here to here is your period, start to finish. Okay, now tangent. Tangent's a different shape. Tangent has an asymptote and an asymptote and a squiggly line through the origin. That's your tangent. Now, notice there aren't any labels on this vertical axis, right? Because the tangent has no amplitude. Amplitude is high point. How high does it go? This goes forever. There's no amplitude. Okay, trick question. What if I put a 5 out here in front? Still no amplitude, right? No amplitude for a tangent. Normally, these labels are negative 90 and 90. You just got to know it. Do you need something, Robin? Oh, yeah. Okay, so negative 90 to 90. Well, what happened? We divided by 2. So now the labels are negative 45 to 45, which means your period, start to finish, is 90.
So basically the period on tangent is those two added together?
Well, one's negative and one's positive, but so if you added them, you get 0. But yeah, it's 2 45s. Okay, now a cosine, which is going to be done exactly like the sine was, except the picture. You have a different starting picture. Now, you also have to pay attention to the fact that that's a negative out there. Now, amplitude is positive, okay? So when you write down amplitude, you're going to make it positive, even though the number's negative. Because amplitude is how high the hills are going to go, and they're still going to go up 1/2. Now, the shape is going to be upside down of the normal cosine. Does everybody see that? Because of the negative. So the normal cosine, remember, starts up here. Well, this one's going to start down here. Oh, I don't know why I'm dashing it. It's going to start down here. It's going to go up and come back down. Now, make sure that you are ending it exactly where you started it. So since it started at the bottom of the valley, it's going to end at the bottom of the valley. We want to know where it crosses, and we want to know where its high point is. So you've got the same marks that you have with the sine: 90, 180, 270, 360. Except divided by 2. So they're at 45, 90, 135, and 180, which makes my period 180 degrees. From start to finish is 180 degrees. Okay, so on Tuesday at this point, you'll turn in that paper, and I'll hand you another paper, and you'll get out your big calculator. And we'll start pressing buttons. So, 128.735 degrees. Am I on the right page? I think I am. Yeah. All right, so I'm going to type in on my calculator 128.735. Second angle DMS. And it says 128 degrees, 44 minutes, and 6 seconds. You can't miss that problem if you have a calculator set in degrees, because this is a degree problem, and you know how to press the buttons, because that's all you're doing. Same thing with the next ones. All we're doing here is pressing buttons. But this is the section where I want you to be really careful. Which of the problems in part 9 are radians? Which ones are radians? Lindsay?
A, C, and E. And B. No, sorry, B, C.
B, C, and E, she says, are radians. So B, C, and did you say D? No, E. B, C, and E, she said were radians. Is she right? Okay, so let's all change our calculator to radian mode. So press mode and highlight radians. And let's do those 3 problems. Okay? So, B, easy. Second sine, 0.514. So B is 0.5398. Okay? Now what about C? Easy. Tangent, 18 pi, use your pi button, which is over on your little raised caret button, divided by 17. 0.1869. And E, easy, cosine 1.3. 0.2675. Okay. Now, all the rest of the problems are in degrees, right? Because they have degree marks in them. So we're going to go to second mode, or not second mode, we're just going to go to mode, highlight degrees, and now we're ready to do the degree problems. We have to remember to make that change. Okay? Now, A is not so easy because I don't have a cotangent button. So I have to remember that I'm going to do 1 over tangent 311. That's how I do a cotangent. 1 divided by tangent. So 1 divided by tangent, 311. Negative 0.8693. Negative 0.8693. And then I'm doing D, and I have a sign button, so I'll just press sign. Then, remember how to do this? 52 second angle degrees, and 11 second angle minutes, and 12 alpha plus. 0.7900. And then F, easy, tangent, 153 second angle degrees, 17 second angle minutes. Negative 0.5033. Now we've worked through now 3 practice tests, right? So you can always go back and retype those into your calculator to make sure you're getting the right answers all by yourself. Those are easy. You don't have to know anything. You just have to be able to type it in. You can all do that. All right, number 10. All right, who knows what I have to do here? What? Oh, well, I need to write an equation, yep. And when I write my equation, I gotta pick whether it's gonna be a sine, cosine, or tangent equation, and it is sine. Because this angle is the important one, and this is the opposite side. If you're crossing through the triangle to get there, it's the opposite side. So that's your opposite side, and this is your hypotenuse. So sine 37. Antoine, you feeling okay? Okay, we'll pick up your pencil. There we go, right along with us. There we go. So sine 37 equals x over 12. Now what? Multiply by 12. Always get rid of your fraction. If you're trying to get x by itself, you got to get rid of the fraction. And then we're done. That's it. What? So I type it in now. So 12 sine 37. And that side is 7.22. Now, this one, same exact situation. We got to write an equation. So you're going to look at it. The triangle's situated a little differently, but the rules are the same. This is the hypotenuse, right? And to get to this side, I have to cross through my triangle. So that's opposite. So isn't this another sine equation?
Yeah.
Only it's going to say sine x equals 18 over 19. How do I type this in? Please don't tell me to multiply by 19. You do not multiply by 19. How do I get x by itself? Lindsay?
You have to do second.
Exactly. When x is the angle, you go straight to your calculator. Just boom, straight to the calculator and do second, in this case, sine. Sometimes it could be second cosine or whatever. So second sine 18 divided by 19. 71.33 degrees. That angle is 71.33 degrees. Farrell?
Why is 18 the opposite side instead of
Pardon me, I can't hear you.
Why is 18 the opposite side instead of the adjacent side again?
Okay, adjacent would mean right next to. It's not right next to the x. Okay, now I'm going to draw a course of 204 degrees. So this problem requires you to use your compass numbers. Now, I got the compass drawn here, but I don't have the angles on it. I just have the letters on it. So where does the 0 go on a compass? North. So your numbers are 0, 90, 180, and 270. That's a compass. Now, remember in normal trigonometry, it goes like this. That's normal trigonometry. That's everything except the compass. But we're using a compass, and we want a course at 204 degrees. So 204 degrees, I gotta come all the way around to about here. Everybody gets that point. Come on. That is so easy. That's all you have to do is draw it. Now, this one we're going to do two ways. We're going to do it exactly and we're going to do it decimally. Now, exact means draw a picture, no calculator. Decimal means type it in on your calculator. So the decimal part is easy. Tangent, second cosine, 2 divided by 5. Whoops. I don't know how that happened. I got to start over. I pressed something I didn't want. Tangent, second cosine, 2 divided by 5. So did you get for your decimal 2.2913?
Yeah.
Okay. Remember when you type that in on your calculator, the parentheses pop up, so don't type any parentheses, just type tangent, second cosine, 2/5. Now, to do this exactly, I need to draw a picture. This notation, positive number, tells me to draw it in quadrant 1. It says the cosine is 2/5. Adjacent over hypotenuse. What do I need to do now?
Find the opposite.
Find the other side. That's right, find the opposite side. So to do that, I will do the Pythagorean Theorem, and I will say 2 squared plus b squared equals 5 squared. Remember, it's always equals hypotenuse. Always. So it looks like, did you get the square root of 21? And it's positive. So now I need the tangent of this picture. Well, the tangent of that picture is root 21 over 2.
Well, what are the rules to know which quadrant is valid again?
If this is positive, it's always quadrant 1. If it's a cosine, cotangent, or secant, and it's negative, it's in quadrant 2. If it's a sine, tangent, or cosecant, it's in quadrant 4. Those are in your notes. Okay. Now we've got our word problems. The test will not have this many word problems on it. So this is just extra practice. Right, so here we go. Guess what we've got? A squirrel in the top of a tree. And we burned through another marker. So we got a squirrel in the top of a tree, and the tree is 64.5 feet tall. He's looking at a nut down here on the ground. The angle of depression is 27 degrees. Okay, so as you know, Mr. Noel left, so I was helping out with those classes, and I'm grading papers right now. They took a test over all this earlier, and some kid put the angle right here. None of us are going to make that mistake, right? Because we've said over and over again, where is your angle always going to go? Right there. Whether it says elevation or depression, it goes right here. All right, the angle of depression, find the distance from the squirrel to the nut. That's what your picture should look like. So this now is exactly like those other problems earlier, where you started with a picture like this, and you have to write an equation now. So your equation will be a sine, cosine, or tangent. So you got to pay attention. This side is the opposite. Look, I'm traveling clear across the triangle to get to it, right? That's the opposite. And this, of course, is the hypotenuse. So this is going to be another sine equation. So I'm going to go ahead and multiply by x. And divide by sine 27. Hey, son! Get your head up. This is the most exciting thing you're going to do all day. 64.5 divided by sine 27. 142.07 feet. Wow, we're mixing it up. We have a pelican on top of our lighthouse now. And he's looking at a crab. The pelican is 93 feet above sea level, and he is 202 feet from the crab. So the pelican is 202 feet from the crab. So where does the 202 go? Hypotenuse. There's the pelican, there's the crab. They're 202 feet apart. What am I looking for? The angle. Is this another sine?
Yeah.
But this time it's sine x equals 93 over 202. Now some of you are already typing, which is awesome. What are you typing? X equals second sine 93 over 202. anytime your angle is the x, you're going to do second something. In this case, it's sine. And the angle is 27.41 degrees.
Oh, how do you put that in your calculator?
Second sine. You type in exactly what I wrote.
Yeah, second sign.
An airplane is currently 4,500 feet above the ground. So here's the airplane, 4,500 feet above the ground, and the angle of depression is 16.3. How far is the airport, this is the airport, how far is the airport from the point on the ground directly beneath the airplane? Isn't that x? The distance from the airport, here's the plane, to the point on the ground right underneath the airplane. This would be the ground distance, in other words. That's the air distance. This is the ground distance. This is not a sine. This is a tangent because we have opposite and adjacent. So tan 16.3 equals 4,500 over x. I hate it when they walk by here and they think you don't enjoy this. Come on. So I'll multiply by x. And divide by tangent. So my answer will be 4,500 divided by tangent 16.3. 15388.8 feet would be the answer. All right, let's quickly get two more done. Here we go. The length of the shadow of a 19-foot flagpole. So we've got our flagpole. It's 19 feet. We're going to find the length of the shadow, and the angle is 59 degrees. Oh gosh, is this the same kind of problem? So we'll say tangent 59 equals 19 over x. Then what? Multiply by x. And then what? Divide by tangent. So those two problems were exactly the same. Hang on, we're going to do the last one. Let's type this in and get that last one done. 19 divided by tangent 59, 11.42 feet. Don't forget to put units in your word problems. And then the last one. Here we go. We have a Precal student looking at the top of a building, and we want to know what is the angle if the building is 51 feet and the guy is standing 200 feet from the building.
Tangent x equals 200.
So there's your picture. The building is 51 feet tall, and the kid is standing 200 feet from the building. So Jaden says this is a tangent problem. Is he right? So tan x equals 51 over 200. What do I type when x is the angle?
Second tan.
Second tan. 51 over 200. So second tan 51 divided by 200. 14.31 degrees. All right, that's it for our practice tests.